Okay, so today we're talking about section 5. Here are the 3 things that we're going to cover. First of all, we're going to talk about how sample size, significance level, and the value of the parameter, how those affect the power of the test. And of course, we're going to talk about what exactly is power. We're going to talk about how to increase power, and then, bless you, we are going to get a sense of how power is calculated. So we're actually going to calculate power. Okay, so this you should have at the top of your note sheet. Power is the probability of correctly rejecting the null hypothesis. Do you think for a given test then, you want a high power or a low power? High power, right? If power is the probability of correctly rejecting the null. Okay, when the null is false, power is 1 minus beta. So power is always going to be between 0 and 1.
Was beta the probability of a type 2 error?
It was.
Okay.
So I was just going to ask you. Yes, beta, if you recall, is the probability of a type 2 error. Why then is power 1 minus beta? Okay, so when the null is false, what should happen? You reject the null, right? What is a type 2 error?
When you fail to reject.
When you fail to reject the null and the null is false. So this is an error. So power is going to be 1, subtract the error. When the null is false, that is. Okay. Do you guys recognize what this orange is supposed to be?
The probability of.
We've talked about this before. Okay. Let me help you out a little bit. It might help you to know that the area of that region is 0.05. This is alpha. What is alpha? It's the significance level. It's also the probability of a type 1 error. Okay, so this is not included in the power, because in power we don't want errors. Okay, so that's a type 1 error. So type 1 is I reject the null, but the null is false. True, right? The null is true. Okay, so type 1 is I reject the null, but the null was true. So that's going to happen if your null is here, and if you get a sample statistic here. Like your x bar falls here, your p falls here, something like that. Okay, what's a little bit more difficult to think about is a type 2 error. So type 2 error means that your null is false. So we always center our diagram or our figure around the null. Type 2 error, the null is false, so our diagram is in the wrong spot. Okay, so here's what a type 2 error is going to look like. Here's my null. Here is the true value of the parameter. Okay, so my null is false, and then in a type 2 error, I fail to reject. Okay, so let's think about that. This is what I'm assuming. This is what is actually true. If this is where I reject, where am I going to fail to reject? This is your beta. That blue is beta. So this is where my null is false and I fail to reject. My null is false because I need a different diagram. Here I fail to reject because it's below the rejection region. Does that make sense? Kind of. You guys with me? Okay. So here's the 3 ways that you need to know to increase power. The first way to increase power is to increase alpha. So if you increase alpha, that's going to increase power. Why is that the case? Karina?
Because beta gets smaller.
Yeah. If I increase alpha, beta is going to decrease, and power is 1 minus beta. If I increase the sample size, I'm going to increase the power. This is the most realistic case. So most of the time, you're not going to increase alpha, you're going to increase the sample size. I did have 2 little clips to show you, but they're not working. Third one is you're going to increase the size of the discrepancy between the hypothesized value and the true value. Okay, so here's what I mean by that. We go back to this. Here is our null. Here is the true value. If I make that difference bigger, so if I take the true value and I bring it to the right, what's going to happen to beta? It shrinks. So the power is going to go up. So these are the 3 that I need to have you memorize. The way this is going to come up in your homework is it's going to say, is power going to be higher when you have a sample size of 50 or a sample size of 100? And you're going to say what? Sample size of 100. It's a larger sample size. Okay. Okay, the first example that I gave you I don't have on here, but we're going to do it anyway. Okay, so it says a drug manufacturer claims that fewer than 10% of patients who take a new drug for treating Alzheimer's will experience nausea. To test this claim, a significance test of pi equals 0.1 and pi less than 0.1. I don't think I finished that sentence. Basically, you carry out that test. You learn that the power of this test at the 5% significance level against the alternative, pi equals 0.08, is 0.64. So you learn that the power of this test at the 5% significance level against the alternative pi equals 0.08 is 0.64. Explain in simple language what power equals 0.64 means in this setting. Okay, so I'm going to write down a few things. Your null is that pi equals 0.1. Your alternative is that pi is less than 0.1. It tells you alpha is 0.05 because that's the significance level. It tells you that the power is 0.64. And then it says against, I think it's against, right? Against the alternative, pi equals 0.08. Okay, so what this is telling you is that this is the true value of pi. So this is what I'm testing. The true value of pi actually happens to be 0.08, which of course I don't know. I don't know, but just theoretically in this case you didn't know that. Okay, what does it mean that the power equals 0.64?
Probability of correctly rejecting. No.
For once.
We were friends, now we're not.
Okay,
Okay, thanks.
somebody, anybody. What does it mean? Okay, say it again because Chris is throwing it fit.
Probability of correctly rejecting the null.
Okay, so I'm going to put a few more numbers in there. So when pi equals 0.08, I will correctly reject the null. (64% of the time). So in this test, if pi is actually 0.08, we're going to correctly reject the null 64% of the time. That's what power is. It's the probability of correctly rejecting the null. Okay, part B. You could get a higher power by changing your sample size. Should you increase or decrease the sample size to increase power?
Increase.
Increase. All you have to remember is everything has to be increased. For C, if you decide to use alpha as 0.01 in place of alpha as 0.05, will the power of the test increase or decrease?
Decrease.
Decrease. If you decrease alpha, the power is going to decrease. Okay, I'm going to add my own in. Okay, so we first looked at if the real value of pi is 0.08. Let's say the real value of pi is 0.06. didn't even ask my question. Using this test, which one will have a higher power? 0.08 or 0.06? 0.06 because it's a
Higher discrepancy.
higher discrepancy. Okay, how do we feel about this? Not too bad? Okay. The second question is where it gets more difficult.
Can't wait.
Okay. So it says, let mu denote the true average lifetime for a certain type of pen under controlled laboratory conditions. A test of mu equals 10 versus mu less than 10 will be based on a sample of size 36. Suppose that the standard deviation is known to be 0.6 and that the standard deviation of the sampling distribution is 0.1. The appropriate test statistic is then z equals x bar minus 10 over 0.1. Okay, so all of that is extra information that you could have found yourself. Because sigma is known, that's why we're using z. So all they did is they wrote a test statistic. What is the alpha for the test procedure that rejects HO if z is less than or equal to negative 1.28? Okay, so we're looking for alpha. Alpha is the probability of rejecting the null when the null is true. Okay, so we are told that we are going to reject the null if z is less than or equal to negative 1.28. So therefore, alpha is going to be the probability that z is less than or equal to negative 1.28. Okay, find that right now. .1003. Okay, did you guys use the table or a calculator? Table. Okay, so that part is not too difficult. B, if the test procedure of part A is used, calculate beta when mu equals 9.8 and interpret this error probability. Okay. So, we need to think of what beta means. Beta is going to be the probability of failing to reject the null if the null is true. Okay. So, it tells us that we reject if z is less than or equal to negative 1.28.
Reject the null.
Oh.
HO is true. Isn't it the same?
Okay, sorry, is this better? Failing to reject the null, but the null is false? Yes? Okay, so we are going to reject the null if this x bar minus 10 over 0.1 is less than or equal to negative 1.28. So if our test statistic is less than or equal to the critical value. If I asked you to solve for x bar, could you?
Yeah.
Yeah? Okay, so I'm going to do it for you. So if you solve, you find that you reject the null when x bar is less than or equal to 9.872. Okay, the reason we need this is this will tell us when we fail to reject. So we're going to fail to reject the null when x bar is greater than 9.872. Okay, so we need to know beta is going to be the probability of failing to reject the null. So beta is the probability that x bar is greater than 9.872 when the null is false. Our null is false because you're told that mu equals 9.8. So this is what we need to calculate. The probability that x bar is going to be greater than 9.872 when mu equals 9.8. So we're going to have to change this into a z-score. So we're going to get 9.872 minus 9.8. 9.8 because that's the true value of mu. And then it tells you that the standard deviation of the sampling distribution is 0.1. So do you guys realize that I'm not dividing by root n because that's what they already did? That's how they got this value? So this value was 0.6 divided by the square root of 36. Okay, so this z-score ends up being 0.72. So this is the probability that z is greater than or equal to, or I guess just greater than 0.72. That ends up being 0.2358. Okay, so this is the value of beta. Okay, and then it asks you to interpret this probability. So I don't want you to say this is the probability of a type 2 error. I want you to give a little bit more information than this. So this is going to be the probability of failing to reject the null when the null is false. So we're going to say if mu equals 9.8, about 23.58% of samples will result in sample means, or x bars, greater than 9.872. And failure to reject the null. Okay. Questions? No? You guys are with me? Okay. So C, without doing any calculation, explain how beta for mu equals 9.5 will compare to beta when mu equals 9.8, and then actually calculate beta. Okay, so beta for mu equals 9.5 is compared to beta when mu equals 9.8. Which one is beta going to be higher? 9.8, why?
Because power increases when you further the distance from the implementation, and you increase the size of the discrepancy between the hypothesized value and the true value. So if you do 1 minus beta for, I'm trying to put this into words.
Okay. Which one's going to have a higher power?
9.5.
Guys, you're all staring at me like this.
9.5.
Look at your paper. We just talked about this. It has to do with the discrepancy between the alternative or the null and the actual value. Which one has a bigger discrepancy? 9.5. Which one has a higher power? 9.5. Which one has a higher beta? 9.8. So this one is going to have a higher power, which in turn means that it's going to have a smaller beta. This one is going to have a higher beta. Okay, so then it asks us to actually compute beta when mu equals 9.5. Okay, so we're basically going to be doing the same process again. Do I have to start at the beginning? Where can I start? Yeah, the z-score. Okay, so this is going to change to 9.5. This changes to 9.5. That changes your z-score all the way to 3.72. So then if you calculate the probability that z is greater than or equal to 3.72, what do you think it's going to be?
Z is greater than 3.72.
Yeah. Pretty much 0. When I did it on my calculator, beta for 9.5 ended up being 9.964 times 10 to the negative fifth. Which checks out. We said that that was going to have a smaller beta, and it did. Guys with me so far?
Yep.
Yeah? So last thing, part D asks us what is the power of the test. Okay, so part B, power is going to be 1 minus beta. So when mu equals 9.8, you're going to do 1 minus 0.2358, which is 0.7642. This is when mu equals 9.8. And then when mu equals 9.5, the power is going to be 1 minus pretty much 0. So the power is approximately 1. Now, in all of these cases, you're going to notice I had to tell you the actual value of mu. So it's really difficult to calculate power for a test because you really actually never know what mu is. With the real value of mu, that is. So in order to calculate power, you're actually going to have to know the value of mu. So generally, if you're going to increase power, or you're talking about what's changing power, you're going to increase your sample size. But you guys just need to remember, increase sample size, alpha, or the discrepancy. How do we feel about this?
Awesome.
Not too bad?
It's not that bad.
Okay, good. Is this confusing?
No.
A little bit? You only have one homework question like that.